Imagine something on the complete opposite side of our galaxy. Tens of thousands of light years away, invisible to the naked eye, reaching out and physically shoving Earth's atmosphere without moving an inch, without any warning. That's not a hypothetical. It already happened. It's not a black hole. It's not a supernova. Most people have never even heard its name. It's called a magnetar, and once you understand what it actually does, you'll never look at empty space the same way again. Welcome back to the Cosmic Vault. Today we're talking about the object that many astrophysicists quietly consider the most dangerous thing in the known universe. Not because of what it destroys directly, but because of what it does to reality itself, just by existing nearby. Let's start with the basics. A magnetar is a type of neutron star, the collapsed remains of a massive star that ran out of fuel and caved in on itself. Neutron stars are already almost unbelievable objects. Take something roughly 1.5 times the mass of our Sun and crush it down into a sphere about 20 kilometers wide, roughly the size of a city. A single teaspoon of that material would weigh billions of tons. But a magnetar isn't just a neutron star. It's a neutron star with a magnetic field so extreme that it breaks almost every intuition you have about magnetism. We're talking about a field roughly a quadrillion times stronger than Earth's. To put that in perspective, scientists in laboratories on Earth have used powerful magnets, nothing close to a magnetar's strength, to levitate a live frog, using nothing but magnetism acting on the water inside its body. That was done with a field a fraction of a single Tesla beyond ordinary. A magnetar's field isn't measured in single Teslas. It's measured in numbers with 15 zeros. Now here's where the story gets genuinely frightening. On December 27th, 2004, a magnetar called SGR 1806-20, sitting tens of thousands of light years away on the far side of our galaxy, let out what's known as a giant flare. In a fraction of a second, less than the time it takes you to blink, it released more energy than our Sun produces in about 250,000 years. This wasn't close to Earth. It was on the complete opposite side of the galaxy. And it still overwhelmed satellite instruments that were specifically designed to observe powerful solar flares, saturating them almost instantly. The burst was intense enough that it produced a measurable echo off the surface of the Moon. And it physically disturbed Earth's upper atmosphere, compressing and altering the ionosphere for a brief period, from a distance so vast that light itself took tens of thousands of years just to reach us. Sit with that for a second. An object we can't even see with the naked eye, on the far edge of our own galaxy, reached out and physically touched our planet's atmosphere in under a second. So what would happen if one of these was actually close to us? This is where science has to be careful, because nobody has ever observed a magnetar up close, and precise survivability numbers are still debated. But the physics gives us a real answer to work with. A field that strong doesn't just pull on metal. At extreme enough strength, it starts to interact with the electron clouds inside atoms themselves, the very structure that holds matter together. Your body is mostly water. Water molecules respond to strong magnetic fields, which is exactly the effect that lets scientists levitate that frog in the lab. Scale that interaction up to a magnetar's field, and you're no longer talking about levitation. You're talking about the basic architecture of matter being distorted. And here's the part that makes this even stranger. Magnetars are rare. Out of the hundreds of millions of neutron stars believed to exist in our galaxy, astronomers have only confirmed a couple dozen magnetars total. They're also short-lived as cosmic objects go. The extreme magnetic field is thought to decay within about 10,000 years, which is almost nothing on a cosmic timescale. We happen to exist at a moment in galactic history where a small handful of these things are actively out there, flaring, unpredictable, and mostly unnoticed by anyone who isn't pointing a gamma-ray satellite at the sky. The unsettling truth is, we don't actually know exactly how many are hiding in our galaxy that we haven't detected yet, quietly waiting for their next giant flare. There's also a mystery magnetars might be quietly helping to solve. For years, astronomers kept picking up brief, extremely powerful radio signals coming from far outside our galaxy, called fast radio bursts. Nobody knew what caused them. Some people genuinely speculated about alien technology because nothing natural seemed to fit. Then, in April 2020, something changed. A magnetar inside our own galaxy, called SGR 1935+2154, let out a burst of radio energy that matched the exact pattern of a fast radio burst. The first one ever traced back to a source scientists could actually study up close. It didn't solve the mystery completely. Most fast radio bursts still come from unexplained sources far outside our galaxy. But for the first time, there was direct evidence that at least some of them come from objects exactly like this one. And magnetars have thrown physicists another curveball. In 2010, astronomers found a magnetar inside a star cluster called Westerland 1, and the discovery didn't make sense. Based on the other stars still sitting in that same cluster, the star that collapsed to form this magnetar must have been at least 40 times the mass of our Sun. Stars that massive are expected to collapse straight into a black hole, not a neutron star. Somehow, this one shed an enormous amount of mass before it ever collapsed, and to this day, nobody fully agrees on how. Astronomers still refer to it, half-jokingly, as the magnetar that shouldn't exist. So the next time you hear someone name a black hole as the scariest thing in space, remember this. There's an object out there that already reached across the galaxy once, disturbed our planet's atmosphere, and left an echo on the moon, without moving an inch. And it did all of that from tens of thousands of light years away. This has been the Cosmic Vault. If this kind of thing genuinely unsettles you a little, good. That means it worked. Hit subscribe, because the next one drops in a few days, and it's just as wild. See you in the next one.